Talk about stop words, right? Okay. And we have stemming as well. Of course, usually when you're done with stemming, chances are there are situations like examples, and maybe something else. Say exemplify, something like that. These are stemming words, and usually they come out with an EXAMPL. Okay, so actually after that, you kind of when you do stemming, of course, that would reduce the dimension a lot. There are several words like repeated in this sense, and only keep one instance of that. And then after that, so like this example, all this could be considered just one term, right? Of course, with several repetition. But when they are stemmed, when the words are stemmed, then okay, I think you already have it. Okay. Most likely, the result is not what you expect. We're going to see that later. Okay. Sometimes you want to do like a stem completion, kind of reverse the process, and so the result will be more sensible when you present it again. Let's talk about that later. So there are two ways. One is stemming, term stemming to reduce dimension. So for example, for this 1, 2, 3, 4, 5, they are considered to be just one dimension only, because out of the 5 dimensions. Okay, so stemming, these are the result of stemming. Okay. And well, here this is that. This is actually important process to further reduce the dimension. Okay. So stemming is a process for the reductions of inflected or sometimes derived words to their stems or base or root form. Okay. The first stemmer was written by this author in 1968. Okay, this is the linguistic application. And the later stemmer was written by this author and was widely used. The de facto standard algorithm for English stemming, and actually package TM was built upon that. So, and Snowball is a framework for writing stemming algorithm developed by the same author. And Improved English stemmer was also implemented around 2005. Because nowadays they are stemming algorithm for other languages as well. Okay, so of course if you are checking like non-English documents, you have to apply the appropriate stemming dictionaries and then algorithms. Right? And when the dictionary was constructed through this white space stripping, I mean that multiple white space will be stripped off. So basically just look at individual words. Okay. And term filtering, or here I didn't add the pass for removing numbers, right? Maybe numbers will be relevant in your documents, text mining. Okay. So sometimes white space stripping, term filtering, including removing numbers, and maybe remove the very sparse terms of private key on one side very, very infrequently. Then you have to remove those terms as well. Okay. And then term stemming. Actually, this process takes us much longer time than we have. Okay. And then when you want to reintroduce the stem word to its completion, so stem completion, it takes even longer. I was trying to come out with this example last night, and I did everything else except I finally tried to do the stem completion. It ran 5.5 hours still unfinished, so I just killed it. I don't want to do that. My computer is slow actually. No, because I took like this 6 documents of this from this Wizard of Oz. Maybe it's just too big document, so. Well, anyway, but this we'll see example later. Okay, I already changed this class note 20.r, so you can download this new version of that, and that includes some added comments and also the word cloud. You can see example of word cloud as well. And when all this process is done, and a document term matrix is then created, okay, through transformation. As I mentioned here, when terms stemming was performed, it probably result into some words very strange like EXAMPL, for example, and then here you have like LITTL. Actually, I came up with that. It's supposed to be LITTLE, right? So anyway, if you'd like to reintroduce that, those are STEM words using STEM computation. You can run that, but you'll be warned that it's going to take a very long time to do that. Okay. Anyway, so after this all done, okay, and you have options to do that, the STEM computation. Otherwise, you can just take as this. Then you can form this document term matrix. It's then created through the transformation, where rows will be the documents. Document term matrix, well, actually the first appears, this is for row. So documents in rows and terms of words in columns. And there's also TM also in, this TM page is also installed the other way. Okay, each one has its advantage. Okay. There's also term document matrix. You can imagine terms will be on the rows and documents in columns. Okay, so actually there's a second one, right? Rows equal terms, so this would be 10 document matrix. That's document term matrix anyway, either way. Okay, here these are some measurements that you can weigh on that. I guess last time we talked about that. Each one has the individual usage. Okay. I guess I'm not going into detail. And one out of this, we use some of this algorithm to calculate the weight of this raw term frequency. I think we're going to use this IDF later on. Okay? This inverse term frequency is defined in this way. Okay, there are some other measures about this raw term frequencies. And last time I mentioned that there's also things about this authorship attribution, and of course you can also use a text mining to do this. The term I mentioned last time, stylometry, right? Okay. Actually, that's an example we're going to see later about this wizard art. So wizard art, we try to investigate in both aspects of that. Okay, this is a short example. We talk about authorship attribution and also stylometry. Okay. Examples. Actually, that's only taken from Vignette, and I add some a little bit more stuff there. Okay. Last time I actually mentioned about this. This authorship attribution is the nearest synonymous terms of stylometry. Okay. Basically, is any attempt to try to infer the characteristics of the creator of a piece of linguistic data. So basically is defined by this. I think this particular author is not only a linguistics professor. I think he's also the computer scientist. Okay. In our course webpage, I have a link to his page. Some resources over there we can look at. So according to the definition, this would be sort of involved out this quantitative linguistic research about this speech recognition. So, well, there are particular types of this authorship attribution. So, given a particular sample of text known to be by one of a set of authors, determining which one. Because this is sort of classification, right, in a sense. Or not exactly classification. Although you know number of groups, but the authorship may not be known, so this is semi-classification. So there's a type of a machine learning problem is sort of crossbreed between supervised learning and unsupervised learning. Or at least the number of groups is known in this case. Okay? And given a particular sample of text believed to be one of a set of authors, different, okay, and we determine which one. So there are many applications. This, okay, and maybe you have something like this, right? You want to identify who the author is, okay, about particular documents. Well, anyway, so the opinions vary. You know, some will just say, some will so include all three authorship attribution. Some just argue that third one is more like stylometrics. Okay. Well, should we look at this? Okay, here we're gonna have this example. We're gonna have fun. Okay, that. So here, this is Wizard of Oz stylometry. I'm not sure if I put a web page on that. And there's a link to a web page where you can download the free books and this Wizard of Oz. Okay. And there are two links that you can go to. Of course, I'm not really a fan of this. I think you better so to explain this. Okay, I think you read from when you're very in very young age, right? Isn't it? Yeah. I think you should be very familiar with this. Okay, so maybe you can tell me more about that. Okay. The first book, I believe, of course, it was written by Frank Baum in 1900. Okay, and the 15th book was the one that long suspected to be actually written by Bruce Thompson. Book 15. Did you get it? Yeah. Sorry. Okay. So the first Oz book written by Thompson was actually the book 15. Okay, and now I think this is generally acceptable that actually she is indeed the author for the book. Yeah. Anyone of you is they read this long-standing fan of Wizard of Oz book? Yeah. Probably I should not get that. Okay. So we know that it's commonly book 15 commonly attributed to Thompson. Okay? Oh, okay. I do have a website here. I forgot. I put it. Okay. So here, these are the two websites. Maybe there are more. Okay, that you can download this. See, for the time being, let me run a part of this Note 20.r because part of this will take. Remember I mentioned about this stemming. Stemming takes about 6 minutes to do that. So, or they run on. Okay, let me put it out and let it run, and then go back to talk about this. Finish that and go back to that. Okay. So for the time being, let's do that. Now, for this, I stick to this. I don't see any reason why it crashed. Well, here, when I say that here, this means that this is supposed to be interactive. So let me turn this off, and then I kind of run through this. Okay, and I can resume that later. Okay? Up to 6 and 7 will be just by itself. So here, this run on this TM, this text mining package. Okay? Of course, here, if you are doing this now, you probably won't be able to run it. Here, I'm assuming that you already have this director. The folder here. I have this folder that is on the parent. It's in the parent direct folder of our current folder. It's under that is Oz book, and there I already have this collection of 6 books. Okay, so let me just point to you to that. Otherwise, you're supposed to have that. You want to sort of practice on this. You're supposed to download this. So here, go to that web page, download this, and I kind of rename it a little bit. So use 01, 02. I want this document to be read in this order. So I order in this way. Here, this is wonderful wizard. Okay, and so okay.
So you have to download first.
Yeah, you have to download these books first. Okay. Or you can see the order of the books that you have. So you go to that web page, download these 6 books, and put them in the same folder, and then try to rename it. Each book was start with a number. I kind of order in this way. So this way would just this would be corresponding to what we are trying to discuss. Okay. So assuming you have that, okay. So then this one, this okay. First, you form this corpus. Okay. Corpus is this collection of documents. Okay. Because with this one, this within this some data structure in R. Okay. So here is the corpus, and then here this directed source capital D and capital S. Okay. And now here this will be the folder that contains those 6 books. Okay. Or maybe documents, right? In this sense, this one is just documents. Okay. So it's a corpus with 6 text documents, and after that, then we form some metadata here. The reason I have it here. Okay, so here this metadata of this tag will be author. Okay, this is type of things that we want to specify, and type is local. This is our local collection of that. Okay, I think there's a way to not to use a type equal local. There's some other ways. Okay, I didn't inspect that. Okay, but you can probably have a choice of that. So basically, the first 3 books are from Frank Baum. Okay, and the last 3 books are, of course, it's a book 4. That's the one that long suspected to be attributed to her. Right. So book number 4 will be this, the Royal Book of Arts. Okay. So here we sort of indicate that first 3 documents are written by this author, and document 4, 5, 6 are by this author. Okay. And then we have this heading. Okay. Be stored in there. Okay. So I basically use a scan function with here these are metadata of this data of this corpus. Okay. We scan when I say what equal this means that this will be the characters, right? The result will be a character, and then I use a new line as a separator, so much easier because here we do leave some space for that. Okay. So the carriage return will be the separator for the vectors here. So here this is vector of length 6. They are characters. Okay. Is that clear? Okay. So this we need to run this, and then let me undo this before I forget. Okay. Let me still comment this part. Actually, this is one I kind of this took me a long time. Oh, this one is okay, but it took me like let's comment here more than 5.5 hours. Still going. Right? Still doing that. That's why I killed it. Okay, I didn't want to complete that because the last check was this morning, like 4:30 or 5 o'clock. I checked it. It's still running, so I couldn't have it here. Okay. So, but here, of course, I explained a little bit, but we will not run that. But for now, we need to run this part, this metadata. Okay. I can run up to this, including stemming. So we'll come back to this later. Okay. Okay, so we come back and we come back later for that. Okay. Okay, so anyway, go to this page. I guess this is the. I forgot which page I went to download this. I think I went to this Gutenberg project website. Did you get to this one? Okay. Okay, so you have this download and organized that way, okay? And then you can start doing this text mining. Okay. The other examples will be this is based from from that also I mentioned about this authorship attribution. Okay. The other example would be about this Federalist Papers. Okay. Well, here this set of newspaper essays published between these years, okay, by an anonymous author named how do you pronounce it? Publius?
Publius?
Huh?
Publius?
I think you're much better than me in American history, so I'm not really, really familiar with this. Okay. So in favor of this ratification of the newly proposed Constitution of the United States. Okay. Of course, here this is just pseudonyms for just a group of 3 authors. Okay. Are they all presidents of the United States, or only 2 of them?
2.
Only 2 of them, right?
John Jay.
Okay. Who is not?
John
Jay is not. So of the 85 essays in total, okay, Jay wrote 5, and Madison wrote 14, and Hamilton wrote 51. That's 51. Because this would be interesting if you look at and try to identify who wrote what. Okay. And 3 written jointly by Madison and Hamilton. Okay. And disputed essays, so maybe you probably, you probably can just play with this data set, this text document, and see, try to do some authorship attribution. Okay? So the 12 among these 12 are disputed, who the author is. Okay? And again, you can download this there. Of course, is to fit in with your memory, probably needs certain computer power, right? So here in our example, we see that this Wizard of Oz example, I only set in 6 documents. Okay, I do have a collection of other books as well, but not in this folder. I put it in other folder. Okay, but here this user's example. Okay? Did you find this one? Did you find this link? Okay. Well, of course, here this is like what the modern scholars is almost voted unanimously on, say, this distributed essays probably should be attributed to Madison. So anyway, but you can actually look at this. Okay. Here, this is some interesting articles to read using Bayesian analysis, okay, pure using probabilistic arguments. You can actually argue that's what happened. Okay. So, well, here this is one of the famous benchmark set of documents that you can test on text mining algorithm. Okay, so some of the data sets that really become famous in benchmarking, say, new text mining method, or in general the data mining method. Okay? Like that, this one is one of them. Okay? Here also from that book, this is example of the failure of this stylometry. Okay. Have you ever heard about this case before? Here, basically, here this is quote from that. Okay. So finally, here, based on the method, finally he said that this author, could not distinguish between the writings of this Committee Farron and the Chief Justice of England because of the failure of that stylometry. I guess this is also a famous data in the text mining. Okay? I'm not sure if we are able to obtain these writings. Of course, we have to look at it. Here. This is supposed to be handwriting, not I think it's not about the content, right? So there's got to be something else that you can see the styles and writings of this document. Okay. Basically, all this research based on these assumptions. Usually, well, we not only have this our Facebook fingerprints, like digital images, and there are something else also have the fingerprint, like writings also certain types of fingerprints. Okay, that can be detected in the writings. Let's see if we have that done now. Let's look at it. Fortunately, it's still running. Here for this statement, I run a procedure, the process time. Process time before that, it's done now. Okay, so here this is the entrance time. So here, this command started at around that time. Okay, this is in seconds, and ended around this time. So how many minutes? Almost 400 minutes, right? I mean seconds, sorry. Almost 400 seconds to run this, okay? Well, of course, depends on the time I run it. Okay, I probably have some other resource running now. So anyway, the stemming is done. Okay, we had done with the stemming. Let's go back to this. Okay, and as I mentioned, the stem completion will be a big problem. It takes a long time to do that. Okay, so what's that? Yeah, I ran it before. 5.5 hours, didn't finish, so I killed it. So I want to continue on that. Okay. So here's stem completion on that. So actually, we can take a look about this in general. Okay, when you have this corpus that you created like this. Okay? Here, this is corpus, and you can look at the first documents. Remember, this is metadata for the first documents, and this is presented. So meta, also one document number one would be this. Okay, this is a variable metadata pairs, and this author timestamp. Okay, this is time I created this the documents. Okay, and description, heading, and ID. So here this ID here we read from that. Okay, and the language used and origin. Here I didn't put origin in that. Okay, maybe I should put the web page, for example. Okay. Okay, so here and then, so all the language here about operating on this would be using this. This is text mining mapping. So here this is just a mapping function. Okay, so basically ask text mining package to map this function on this corpus. Okay. Okay, so here strict white space and to lower. You can guess what that is, right? Change to all lower cases. Okay. So we don't want to distinguish between uppercase and lowercase. Okay? And then remove punctuation, for example, because that's also a non-important step, right? And so here, this step is sort of filtering, right? We're removing numbers, okay? And now here, this step is apply this, we map this document with this function, remove words, okay? And those are the stop words. Remember we mentioned about those stop words, right? Okay. So basically here, this is a dictionary of those stop words for the English language. I guess you can use help stop words there, maybe stop words for other set of, maybe other language as well. Okay. This didn't take too long, about 70 seconds. So this one, okay. But it takes a long time to do a stemming, and even much longer time to restem or just do a stem completion. Okay. So here, apply further stem documents. Okay. So almost 400 seconds. Okay, so now we are done with this. Well, actually, we can also try to at least amend, just a kind of, okay, what should I say? I shouldn't say repair, or maybe I should repair the result a little bit when we present the result. Okay, I'll show you that later. Okay. The idea of this stem completion is basically at the time you do all the filtering and removing stop words, stemming, and then you form dictionary of your corpus here. So here, basically this is just the same corpus. Okay, and this dictionary was formed first, and after that you do restamping. So stamping just try to compute. Oh, maybe that's why. Oh yeah, here, right here. Okay. Stamp completion has to compare with your original dictionary, right? That's original corpus. So it takes a long time to do that. This is a huge sort of, well, it is a kind of large collections of text within this. Okay? And now we can form term document matrix by collecting, well, in the corpus, for example, here, I kind of collect the first 3 books all together as just one term document. So here, by this thing, you know that terms refer to words, right? Documents, so there are how many documents? 3 documents. So it's supposed to be 3 column term document matrix. Okay? You can actually look at the dimension. So this one, all this one, the first 2. Okay? So here, first look at the dimension. Here they are all together. If you look at these first 3 documents combined, they are all together this many terms or words in there, okay? And with 3 columns, because 3 documents, right? And then there is a further reduction of dimension. If you allow the removal of sparse words, okay? Or well, of course, sparse terms or sparse words, okay? So here, use a maximum allowable sparsity of up to 20%. Okay, so if this term frequency is less than 20%, okay, we can remove that. Okay, so we only look at the more frequent terms that appear in the documents. So after that reduction, you can see that we reduce to this many dimensions. Okay. So suppose we are not so interested in those least frequently occur terms, that we can do this instead. Okay. So let's do likewise for the other. So here we try to single out document number 4 because this is the one that we'll probably try to identify, right? Okay. So single out this document number 4. This is supposed to be 1 column term document matrix, and with the removal of further term, let me finish the rest. Okay. So this has 1 document, document number 4 actually in this corpus, and this combination 10 document matrix has 2. There are 2 documents. Okay, and you do a reduction in this the sparse terms. Well, here I just use the example directly. This find 63 most frequent terms. So probably there are some rationale about choosing these numbers. Okay? I didn't actually look at it. Okay? But for example, from the first 3 books, we find these words. Okay. This probably the minimum frequencies. I actually didn't go check that. Okay. Anyway, but here let's just run this. Okay. Now we can always use help documentation. Look at this find freq terms and see what this number is. This one. Maybe we just do that. Okay. Here, that's a low frequency bounds. So, well, here basically you find that, well, here, where is our, did I run this already? Yeah, I run the first one, right? Okay. So here this is lower bound for the frequencies in this one. I guess it makes sense here we have like 60, use a higher number because here this collection is 63, I mean the 3 documents, okay? And then here this is the one that is at the center of this associated attribution, so we're going to look at more, okay? So lower bound of the frequency. So a term should appear at least that many times to be in this collection, okay? So basically that's what it is, okay? And you can run intersection of this, okay? Let's see what happened here. The intersection between book number 4 and what is that? Book 5 and 6. Okay, there are 17 terms. It looks like this is counterintuitive, right? Okay. Now here intersections between Baum and Royal looks like it's more alike. Okay. Probably that's why it is so difficult. Just by looking at this frequency alone, probably not so easy to identify. And of course, there are some other aspects of this. You need to look at the style, okay, of the writing. And this TM package has this built-in function. And basically, this is for mining the text mining. This is principal component analysis with a different algorithm. This from this library, okay, it's a faster algorithm, okay, more efficient algorithm to mine this type of data. Okay, so let's run, I suppose, the data set in this format. Okay, we run this kernel and look at the chunk size. Okay, let me run part of this. So here we determine to make chunks of 500 terms each. Okay, and actually most likely you can look at the chunk size like which is not 500 means that that's the end of that document. It's more likely it will be the junction between 2 documents, right? So the first document run until this, right? Okay, and starting from second document, right? Okay. So last chunk will be the one that is less than equal to the 500. Okay. So basically here these are some simple ways to look at it, and there are a total of 6 documents because here you have this 1, 2, 3, 4, 5, 6, right? Okay. So making this for that 6 documents. Okay. And the relative size of the different chunks. Okay. So here the first documents are the first 11 chunks of the result. Okay. With 500 each for the first 10 chunks, and the 11th one will be this one. Okay, there are 123 terms in it. Okay. Well, this suggests this kind of plot. Okay. Here up there, when we work on this, okay. The features, this is the number of feature vector we want to extract from this principal component. So basically there are 2 principal components we extracted. Okay. Remember we mentioned before that principal components, the first 2 principal components will capture the most of the total variation, right? Maybe capture 80, maybe it's 90% of total variation. Okay. So suppose we extract only 2 features, okay? Because that would be easier to look at this. Look at the plot in this way, because 2-dimensional plot. Okay. So here, this is plot. Let me do this identification of the documents here. Here I need a locator to locate this. Just put here. Yeah. It's always hard when I, translate that into. Should I redo this? But probably. Put it out of place, so probably easier for us to see. Put it here, okay. This is still cut off. Okay, too long. The name is too long. Okay. Maybe I can use a smaller font for that. I didn't put a smaller font. Okay. So anyway, here these are the two principal components we plotted over this from this result. This first principal component, second principal component. Okay. These two combines account for the most variations, the total variation. Okay. Among this, is it easy to see any pattern from this? Well, there are some patterns, but not so easy actually. First three are in this plotting characters. Okay, so that's the first group of documents we look at, and the one at center will be this. Okay, the Thompson's Story Books of Art. Okay? And here the last two documents right here. Okay. Are you able to say that this book number 4 is actually closer to these two books than to the other two books? It's not so easy, right? They sort of intertwine with this result. Right? Well, of course, at this we can see that for the first 3 books they lie more toward this direction than toward that, right? Maybe you can argue that. And then here, the Royal Books is more leaning toward that, and then that is associated with all this. Maybe there's some similarity there. Now, suppose this time I make a different chunk size. So instead of cut them into 100 chunks, okay, and 500, I cut this in like hundreds and using a different weight. Here we use the inverse. This is TF IDF. Remember that's the way we look at it before, right? From that. When was that? When did we talk about this in here? This is weighting the raw term frequency. IDF. Okay. Right here, right? Okay, this is term frequency using the IDF. Okay. So anyway, let's go back to our discussion. This is meant to be it's only introduction. So and TM has this vignette, so we go to that look at the vignette, okay? But not this word cloud. Okay. Let me run the rest. This is our second way to look at it. Okay, it's pretty fast actually. So we have this 100 terms a chunk, and then so here more likely here this is junction of it. So that's why the first documents has like 52 chunks, right? They are all spread out 52 chunks. Okay. The first 51 chunks have each one having 51 terms. Okay. I mean 100 terms. Okay. Where are we at now? Okay, so let's plot this in other views of this result. Okay. I hope I have enough space for that. Yeah. This is better than before. Here, distinctly, this last book was book number 6. Okay, it is sort of very crowded to this. Okay, so mostly explained by just one principal component alone. You can see that, right? Okay, it has a lot of okay. Just sort of crowded to that, but still, this is still hard to explain. I lost this. Well, can you say anything about this? Of course, here it also depends on how we divide this. Okay. Something right here. Okay. Here I remove the sparse term I allow that to like a 50%. Okay? Maybe this is way too high, maybe you want to decide with a small one. You can try to use 0.2, it doesn't work because 0.2 will reduce to 0 terms. There's no terms at all, okay? But you can try other number, for example, maybe reduce down to 0.25 and run this, okay? So we do that, okay? fun. It's kind of fast, so we can actually do that.
Exploded.
So also depends on how you look at it, right? Okay. How you extract. Okay. Sometimes, curiously, they all form this one. I have no explanation about this. If anyone can come up with explanation about this. And then here we limit our the maximum sparse term will be like 25%, okay, to be removed. So anyway, let you play with this. And here, this also this Binongo. How do you pronounce this? I think this is this a Spanish name? Anyone can pronounce this name for me? Is that Binongo?
That's how it's pronounced in Spanish.
Huh?
That's how you would pronounce it in Spanish.
Exactly. Okay. But this also has written a document. I mean, an article in Chance magazine. So you can go there and look at Chance magazine. In fact, you can download the entire issue of that Chance magazine, and you can look at that stylometry. So here, this is sort of interesting article talking about stylometry. Okay. And he looked at these kind of words. This is like a sort of looking at the styles, how this also used. Okay. Let me, of course, here this is from standard input. Right? So let me remove this header here, so and make sure everything read correctly. Okay, so read the data in a standard from standard input. Okay. And we form this document term matrix. So instead of looking at other terms, we look at this. Okay, the terms that of interest in this. Okay, in this document term matrix. So of course this is much reduced data set, right? Okay. 4 terms or words.
Column names.
Of 6 documents, right? Here this is document term matrix. The rows are documents, columns are terms or words. Okay. Of course, some of these words has to be combined. Okay. Like here, we should combine this and with that, okay, among other pairs. So here, the following step is basically try to combine that. So reorganize your matrix. Okay. So I combine column 1 with column 5, so it's added together. They are supposed to be just sort of same style, same words, okay? And then here, so column 1 and 5 will be added together, so added with like frequencies, of course, okay? And column 2, 3, 4, okay, forward that, and then, of course, here we kind of skip this too because they already combined. 6 to 28, and then 29 and column 30 is supposed to be combined, okay, among others, okay? So basically, here, this is a step like process this data set, okay? And finally, you form this data frame, okay? Frequency with this, and suppose we only take a subset of that. Okay? So here, this is only the first 300 terms of the result, and that's part of the result. So we can see anything. Where is that? Here, these are the first 3 books, okay? And here, this is a book at the center of our investigation here, and then the other 2 books right here. Can you see any pattern here? Here, the Y scale I use is so-called slice. These are the slice scale, meaning that you have same units of, you have same data units, except that the scale is probably a little bit off, okay, up or down. Okay? So, see, like here, this is from 5 to 15. Would be the same from 5 to 15 here, but although location, for example, here, this is 5 to 15. So same units, okay. So Y scale basically the same units, except that I do a slice of the result, okay. Can you see any pattern from this? for me, it's really hard to trace that, but probably you can see something. Okay. In other terms, that so least frequently used, except for a few of them, and maybe you look at how about this? Okay, well, let's not say term. The word that and those used. Where is that? Okay. Here, book number 4. Okay. She used that a lot, right? Isn't it? Okay. According to this. So is the height of, I think the height is near 30, right? Isn't it? Okay. And compared to others, I don't know how you see that. Okay. Maybe you can. This is probably the document. See the writing style probably is so much close to the first 3 books, so it's really hard to identify that. Okay. But of course, there's still some discrepancy. You can see that in this part. Of course, if I would use a D4, okay, all this would be in same scale, and then of course they will squeeze much more, so it would be even harder to read. Okay. But here, this is probably the best I can have for this result. Okay. I did this, I can try to interpret this result. Okay. And finally, for those the combined books we have in this 10 document matrix, remember earlier we had combined these 10 documents and also reduce dimension by remove sparse terms. So let's say, suppose I take this, okay? I take this document, Max, Mom, and Royal, and then Thompson's book, okay? So they are sort of 3 set here. Let's run this the word cloud presentation result. Okay. To run the word cloud, you need to install this library, the word cloud library, okay. And turn that 10 document matrix into regular matrix, and then you can do the result. Okay. And we can sort the column according to the decreasing order, okay, of the raw total. Okay. Just remember all these are the what was that? These are this is 10 documents, right? This is 10 document matrix, right? Rows are terms, right? Okay. So we sort of rearrange the rows, okay? According to arrange the row according to the decreasing order of the total. Okay, so we want to look at most frequently words first. Okay, so suppose we do this. Okay, let's run this all together. Okay, and look at the word cloud. Okay. I think you see this a lot, right? Isn't it? Okay, this is word cloud presentation. But I'm here. This is actually the title I put up there. Probably I should leave more space here. This is it. Well, but when I didn't use a projector, it didn't run that. The title didn't run that close to that, so okay. Maybe it's okay. Okay. See, this is what I meant that like this one. We didn't do stem compression, so you see words like this. Okay. And most frequently occur words is what? Or maybe Dorothy, right? Either one. Okay. Well, actually, you can see that where it was. Okay. We can actually see this. Okay. Let's look at the first one. Okay. The Dorothy appears most frequently. The stop words, unfortunately, this. Okay. So maybe you can sort of repair that. Okay. Basically, these are the columns with that, so very easy to fix. Okay, scarecrows come next, and woodman, tin, little. Okay, anyone recall why that words come up so frequently? I mean, this one, little.
The dog.
The
Oh,
dog.
little dog. Okay, okay, got it. Maybe it's just you have a dog there, right? I don't know. Okay, anyway, so here. Let me just put up another Windows and run this for the second book. Okay, Of course, in this word cloud package, there is a comparison cloud command as well. You can use that. Okay? I didn't use that command. Okay? I want to put that in a separate window. This is Royal Book. Look at that. It's not so easy to look at in one screen here. Okay. So here, Scarecrow come up the most, right? In this Royal document. So anyone recall why that is? This is the center, almost the center of that book. Does that book talk more about Scarecrow?
I didn't think the later books were as much about Dorothy.
Oh, really?
They were more about the other characters.
Oh,
I
okay.
don't remember that. It's been like that.
I guess I have no clue about what was for that. Okay. And now let's look at this. The actual we know the Thompson's book, the last set of that. Okay? So here, this is the Thompson's book, right? The last book number 5 and 6. Okay. Here, let me just try something that you can sort of prepare this stem words a little bit now, but this for the presentation. For example, I'm just saying. For example, here I try to sort of repair this, right? Or do stem comparison. It's supposed to be little, and here castle, right? Okay, and suppose you try to do that. And let's look at how this is going to be done. Okay, in R. You can actually see that. Or suppose I try to repair only these two words. I can first identify where that is, okay, where this word is located. Okay, so you can use that. Okay, and then just you can actually see the names for that on the console. So here, run this command. Okay, so which names from that collection exactly correspond to this stamped word? Okay, like this. This is not good sign. Yeah, my computer doing this to me very often. It's not a good sign, so it says something stop working. Okay. Okay, so here, these are the two names we want to sort of repair, right? Or so do a stem comparison. We can do it manually, of course. Okay, just for the presentation. Okay, of course there are some other words we probably need to sort of repair as well. So then after that, I run this. Okay. We sort of change that back to it's supposed to be. So now you can see that it's. So just do it manually. That's all. Okay. Very easy to do that. Okay. Because if this is really important to your presentation, then take a look on that, and then let's run this word cloud again. Okay, so of course you can repair ours in here. I remember these are arranged in a random order. I do it randomly. Okay? You have choice of say fixing in the same order. Okay, so the words can they can rotate. Okay, vertically, horizontally, different way. So the two words, castle, little, we actually just sort of manually repair that, okay, for this for the presentation, okay. So now let's look at. Of course, if you like, you can also use to make it more appealing using different fonts or different color scheme. Okay, these are just a couple examples. Let me just run this. And then take a look at that. This is from the active window. Use this Gothic English. You can present in different way with colors. Well, this is what you see very often from web page, right? This is what you see from a web page. Okay? And one more. And I finish with this word cloud. Where is this? Here I use this is grayscale. The most important words would be, well, of course here in this case, wizard, right? Not only with the darkest color, but also the largest font, right? The font size. So they gradually reduce the size and then also the shades gradually. Okay. You also see this, right? Isn't it? Okay. This is word cloud. Now, if you want to do a comparison, in this word cloud package, you also have this comparison cloud. Actually, I didn't go into that. But here, you can do help documentation. They have this. Okay. So here, this is a command to do that. Okay. Comparison cloud allows you to compare two documents. Actually, it's not so difficult to do that. You can actually see the example right there. Okay. Basically, all you have to do is have 10 documents matrix, which we actually have, right? For example, you can restructure. You can take Thompson's book number 4 and then combine with, for example, document number 3 or document 1. Okay. With the 2 documents. I'm not sure how many documents you can compare with word cloud, so maybe we'll make them smaller. But anyway, comparison cloud would be like this. Okay. I didn't investigate that this commonality cloud. Maybe look at the common words or something like that. Then take a look at that. Okay. But it would be interesting to look at this, like presented your text documents like in this way. Okay. So anyway, for this class note, this is just meant to be only very brief introduction about text mining. Of course, this is not the only application with text mining. Right? You can mine the like documents over the internet, right? Mail, for example, you can spam mails from internet, okay? Using some criteria, of course. Okay, so there are many applications of this. Okay? I guess. I'm not sure if you do you enjoy this course or not. Okay, there are interesting problems here, right? Just too many things to work, but we have so limited time. Okay? So anyway, I thank you for. I think you've been very good and look at what you did on the case study. But you have, of course, doesn't mean you don't have to turn in case study number 5, final project. You have 2 more things to go. Okay. So case study 5 due on, what was it? Did I say next? Is it next Wednesday, right? In project Thursday. Okay. So make sure you have them. Okay. Okay.
That's a degree, maybe.